I'm Scott. Welcome back to Canard Boulevard. Today we are going to be installing the Monkworkz emergency backup or alternate backup alternator on my Cozy. Coming up. So my Cozy has an electronic instrument panel, radios, EFIS, everything is electronic. If I lose power, I'm in big trouble, especially if I'm an IMC, an instrument. So I'm going to be putting a second alternator on, a backup alternator that Monkworkz makes, and it bolts on where the vacuum pump would go if this airplane had a vacuum pump, which it doesn't because it has all electronic instruments. This alternator can provide 30 amps, so it will run the entire airplane even if my main alternator fails. So it's perfectly capable. In fact, I could probably, if my main alternator was failed or I broke a belt or something, I would be perfectly happy flying with just this backup alternator because it can provide more than enough power to run the entire airplane safely. All right, so let's get to work on installing the Monkworkz backup alternator. So if I move this hose out of the way, you can see the pad right here where the vacuum pump normally mounts, and that is where the backup alternator will go. And we should have more than enough room to get it installed in there. It is pretty tiny. I looked at other alternators such as the BNC, and it's just too big. There's no way I can get it to fit in here with all the stuff I've got. So that's why I'm going with this Monkworkz. Plus the Monkworkz puts out more power, and it has a very intelligent system where it will turn on and turn off itself as needed if the main alternator fails. And it has a lot of other protection circuitry in there and intelligence. It's got a microprocessor in there so that if there's a dead short, it will shut itself off. Or if it sees overcurrent, it will shut itself off. So all kinds of protection in there. Normally, it's the kind of thing that you might get provided with fuses or circuit breakers, but instead we get that with the Monkworkz alternator in the intelligent box that handles all that for us. Now we do have to provide some cooling for this, and that's going to be a little bit of an issue, and we'll talk about that in a few minutes when we look at the alternator itself. All right, so all the fasteners are off, and we got to remove that cover, which is going to take a tool to do. There we go. Just encourage it to come free. And there we go. There's the pad that we will be replacing with the alternator. So I'll get a cloth and we'll clean all the schmutz off of there and then get the alternator out. I smell a cigar. I can't believe I'm at the airport. The airplane's full of hundreds of gallons of 100 low lead, and someone is smoking a cigar. Unbelievable. All right. That's nice and clean. Let's get the alternator out. So here's the box in which the alternator comes. Cooling tubes, which we'll talk about momentarily. There we have a new gasket, which we'll be using momentarily, and all kinds of connectors and good stuff. This is the control box that controls the alternator, turns it on and off, adjusts the field voltage, rectifies it, and so on. If I can get it open, I will show it to you. So here's the control box. You can see it does have status lights, and here's where the alternator plugs in and the alternator control wires. Here's the output to the plane and the battery and some other control wires. This is a cooling port. You can see we have air that goes into these two regulating devices here. So we take three-phase AC from the alternator, and this rectifies and controls it, and we get our output over here. One issue is that the intention is for this tubing to be hooked up to your baffling, and then we have blast air going in here that cools this stuff and the exhaust comes out here. Unfortunately for a Canard, that doesn't work that way. We don't have a tube that we can blast that. So I'm going to do the same thing, but I'm going to hook it up backwards. So this still goes to the baffling and it's going to suck air out and the air will go in this way. That's the hope anyway. Then here we have the actual alternator itself. It too has a place for the tube for the blast air to go in for cooling. Again, we're going to suck that out. These are what are intended to be the exit vents. I'm hoping and expecting that because this is going to be in a high pressure area and the tubes will be connected to the other side of the baffle, which is a low pressure area, air is actually going to move through this backwards and keep it cooled. If not, then you can see this turns with the engine. Then I will machine or create some vanes that will go into these machined holes here that when this spins, it will actually grab air and blow it in through it and then exhaust out here. Here's where it connects into the accessory drive on the back of the engine, and there's a shear coupling in here, so if anything were to seize here, it doesn't take out your engine. Here's the high current output, 3-phase output wires, and then the control wires that connect into our control module. So let's put the gasket on there and mount this in place and see how it looks. So let's see how we're going to position this. Put it like that. Then the hose can come up right up through there, and I think that'll work just fine. So let's put it in that direction. We'll position the gasket over top of it, just like that. Boy, it's not happy about going on that stud on the bottom there. There we go. Okay. Actually, all I had to do is rotate the case a little bit to get it to go in. That's fine. Okay. As you can see, I moved the propeller and the housing moves. That's good. That indicates it is engaged. And now we'll just put all our lock washers and nuts and hardware back on. So that's installed. We got those 4 bolts on, and anyone who's ever taken a vacuum pump on or off knows what a bitch it is to get to that last bolt under there. That took all the time. Now we have to figure out where this is going to go, and it should go somewhere where these wires are going to reach. So it could go up there, and I think that's probably where it's going to go, because right behind that is the battery, and then I can just feed wires through right there to the battery. So let me do some measuring and make sure that where we drill holes is going to work, and we'll mount that up there. I think that should be perfect. And then these wires can come right up under there. I won't even need to trim them, I'll just terminate them. And will these wires reach? Yes, they will. Yeah, I think that's going to work perfectly right that spot right there. So we'll put it right there. Okay, let me do some measuring. All right, so we made some progress so far. You can see the actual alternator is installed there, and if I turn the prop, you can see it moves. So we have the wire harness coming up here. I did have to extend it a little bit because I was short by about 1 inch. But we have the control box up here. We get the 3-phase coming from the alternator, and it doesn't matter what direction or which order you connect those, because it's 3-phase AC. It's all the same. And then we have a thermistor here. I've disconnected and cut away pin 1, which tells this thing that it is a backup alternator and not a primary, so it adjusts the voltage that it's going to put out. And then next we have to hook up the outputs, and that will involve putting another shunt so the EIS can measure the voltage, or the amperage rather, coming out of this. And I also have to put an indicator light and a switch up on the panel to be able to control that. So that is where I'm going to leave this for tonight. I also have, before we go flying, I've got to yank this electronic ignition out and replace it. So that's a pretty major job, but we made some good progress. I've got this since at least the physical installation done. Got some more electrical work to do, but once that's done, that should be good to go.
the next day.
So here you can see the baffle outlets. This is on the back of the engine facing the low pressure area here. And then those tubes are the supplied 3/4 inch flex tube, one going up to the control module and the other one going down to the alternator itself.
Eventually,
The alternator project is complete. It's installed. You can see there's a lot of wiring that had to be done to get everything hooked up and working the way that it should be. Let me show you how we ended up hooking all this up. So as you know, we have the auxiliary alternator right there, and its cooling duct goes out to the back of the baffle here. Now remember, this is a Canard, and the cold air comes up from below, and then it blows up through the engine and then out through the back. So this is the low pressure area, this is the high pressure area, so this is where all the cold high pressure air is, so it blows into the regulator and into the back of the alternator, and then out there, and then out through into the low pressure area back here, just like it does with this duct right there. And boy, is that sharp. I need to fix that. Here is the regulator here, and you can see I've got all the wires hooked up to it now. Here we have a ground that runs down to a ground right there. That's the same ground that actually runs to the engine. So that's a very good ground. Over here we have the input, the 3-phase input from the alternator along with the control signal from the alternator. And then out here we have all the control signals as well. And that is, you can see it braced there, and that runs up to the front of the plane, which I'll show you in just a moment. The positive output runs through there into this grommet and this hole that I've just created, and that hole is actually going to be used also for the new EIS. So I've run that in that hole, which is why you see some other wires down there, because that's the next project on the list. You can see that runs in here through a 40 amp fuse into the main bus. Down here we have the Garmin EIS, and the shunt voltage from the alternator runs into there so that I can get the voltage or the current that is producing on my G3X. And up here we have a button that is not yet labeled but will be. This is the auxiliary secondary backup alternator enable. So when this button is pushed in, it enables that alternator, and it has a light in there as well that lights up, that lets you know that the alternator is actually active and generating. So you could leave that pressed in all the time, and the only time that light will come on is if the main alternator fails. So I could be flying along here with this turned on, that light will not be on. But if I then turn the main alternator off, or it otherwise fails, this light will light up and it will turn on, start generating power, and we'll see it on the G3X, which I have not yet programmed, but I'll do that soon. All right, so I've configured the G3X. Here's my original alternator shunt, and the second shunt we have here. You can see I've got it set up so we have some markings. It's a 30 amp alternator, so if we go above 30, then we are going to get an alert. It shouldn't be able to do that, and it's also going to let us know if we get to 26 amps because we're getting close to capacity. And we also, in this one, we changed the scale factor to 0.45. I'm not sure, 100% sure that's going to be correct, because the shunt inside this alternator is not a 50 millivolt per 100 amp shunt. It's a little bit different. I did some math, and that's what I came up with. I'm thinking that should be correct, but we'll find out. Once we do start up, and I should be able to run that alternator up to capacity, and if it's indicating 30 amps on here, then we know it's good. The only thing left we have to do is to run the engine and test the alternator. Unfortunately, I can't do that yet because I've already started pulling apart the old electronic ignition system. And so that will be a test. I'll be running the electronic ignition system test and the alternator test at the same time, but I'll put it in this video.
3 days later.
What didn't work was the alternator. I turned it on and nothing happened. So there is a status light on the alternator itself that will tell you what's going on.
but I obviously can't see it from here. So I'm gonna have to rig up a camera or something so I can look at that status light and see what's going on. Although I have a feeling this is supposed to be flashing as well, if that's the case. But we'll check that out and see what's going on.
Well, as you can see, the light was flashing 3 times, which means it's disabled, which means it's not seeing the switch. And looking at this, I think I see why. Because pin number 6, which is the ground that enables the thing, is pushed out of the connector somehow. So let me fix that. All right, so now it's seated in there, and I actually had another one of those pull out while I was working on it. So it's seated in there now, and I gave it a more space here to adjust between the individual pressures on these wires. I'm honestly not a fan of this little tiny Pico connector. I wish there was something a little more robust there. I think that should do it. We'll see how that works. Let's give it another try. Okay, I did some math, and I think I've changed the correction factor from 0.45 to 0.57. So let's see if that works. All right, so that I think was a success. The alternator is working. I can turn it on after I start up, after the initial recovery, and it will sit in standby mode and only turn itself on when if the main alternator were to go offline. I'm not thrilled with the indicator light. I saw it flickering there. You saw it work for a short while, but I have a feeling it's that same connector because that's what activates that light. And all it has to do is provide a ground to that, and that light will turn on. I tested it back here providing a ground directly, and it works fine. So that's, to me, seems to be the connector is the issue. That's this finished. I think my next task is to go eat some dinner and then come back, start with the fuel filters and all the other little tasks, and then put the cowls on and get the airplane ready to fly for when I come back on Monday. I was just sitting here thinking about how the light on the alternator was not turning on. And I realized why is because I did not have the panel bus turned on. And I wired the positive for that light into that panel bus. So obviously, if there's no power going to the light, then it's not going to turn on. I guess I could have just put that on the essential bus, but I didn't think it was that important, just an indicator light. You're going to know if the alternator is running because it's going to show on the G3X that you've got amps coming out of the alternator. So not a big deal, but I just figured that as I was sitting here and thinking, oh, I know why that's not working, and it's not the fault of the unit itself, it's just how I installed it. Something interesting I just heard, I've been running the engine with obviously with no airflow over the cylinders, so even though it's just idling, the cylinders are baking. Do you hear that? That's the sound of fuel boiling in the fuel injectors. That's vapor lock. That's why I was having more and more difficulty getting the engine started, is because the fuel is so hot from baking on top of these cylinders that it's actually vaporizing and boiling inside those fuel lines. There, I just heard it again. And that's what vapor lock sounds like.
3 days later.
Well, we had a weekend of thunderstorms and tornadoes and all kinds of nasty weather. It's now Monday. The cold front has come through and pushed through all that nonsense. And it is a bright and sunny day outside. So we are going to go up and do our test flight. It is cold today, 42 degrees, so about 10 degrees Celsius. So we should get some decent performance. I am being very, very attentive and careful on this flight because this is, statistically speaking, the most dangerous flight you can do. This is the post-maintenance test flight. I have modified both the replaced both ignition systems. The magneto was overhauled and replaced. The electronic ignition completely replaced with the new system. So I've replaced both of the ignition systems. So that's that redundancy there. And then obviously I have the new alternator in place along with some other wiring. So I've done the work to the absolute best of my abilities because I know my life depends on it. So I'm going to be taking things very carefully, really watching the performance, temperatures, voltages, everything. And I'm going to do an absolutely top pre-flight. I'm also at the point here where I have not flown for several months because of the winter and because the airplane's been apart. So there's that on top of it. So got to be on my absolute A game here and get up, do the testing, come down and see how we go. So let me start with the pre-flight. If we have not reached 60 knots by the turnoff, we will be aborting, full on brakes, idle cutoff, stop by the end of the runway. If we have an engine failure below 400 feet, straight ahead, land straight ahead. Above 400 HEL, which is a 1600 MSL, we will do a right turn, right 270, land on 19 south. Oh, I was going to do the alternator test, so let's do that now. I'm going to shut off the main alternator and turn on the auxiliary alternator. And I got nothing. No power.
County traffic, organized through Mike Alpha, 7 to the southwest.
Alright.
Gonna do midfield cross to 9.
So it looks like something's going wrong with that auxiliary alternator again. I have a feeling that connector may have just vibrated out, but I'm going to turn it off, turn on the main alternator again. That's disappointing, but I was kind of half expecting that. I definitely need to RTV those connectors in place. Well, we'll have a look at the alternator and see what's going on with that. And I guess I don't know. I'm going to look at it tonight. It's a little too cold out. It's going to get down to freezing tonight. But tomorrow's supposed to be nice and warm, so we'll come out tomorrow, pull it apart, and see what's going on with the alternator, and give it another test flight. Medina traffic 797, definitely clear to 7. I have a feeling it's just that same connector, and I'm going to have to RTV it in place. That'll fix it. Although if it is that connector, I probably want to RTV it tonight so that by the time I come out tomorrow, the RTV is cured, because it does take 24 hours to cure. So maybe I will look at it tonight. Well, I'll shove a camera in there and at least see if that's what's going on. That'll give me a good idea. Alright, so let's get in there and have a look. So it's definitely that same connector that's come out, the ground on there, and that's why it wasn't working. So I guess I'm gonna pull this off and RTV that thing in there so that it can't pull out again, because I can't have that just coming out in flight like that. And hopefully that's gonna solve it. So we'll do that. I'll let the RTV, I'll pull the cowl off, put the RTV on there after the pins reset, recowl it, and we'll give this another try tomorrow. All right, so what I've done is I've put a zip tie to lock it to that wire, which I probably should have done originally, and then I put a dab of RTV there to hold the wires into their connector so that they can't come out. So I'm hoping that's going to fix this issue, and we'll find out tomorrow. As you saw, I did have a problem with the alternator. That's been fixed. And the way I fixed it this time, I don't think it can go wrong again. We'll go up again tomorrow and try that out. Not entirely how I expected this to go tonight. I was hoping to see the alternator running great and not over-temping and all the rest of it, so I wasn't able to do any testing on the auxiliary alternator tonight at all. But I have gone in and fixed it. I've secured it with a zip tie, as also I've secured the individual pins, RTV. That will cure by tomorrow, and with any luck, we'll go back up tomorrow and do another test with the alternator and see how it goes. I'm expecting it'll be fine, but we'll see. All right, that's it for tonight.
Tomorrow.
It's the next day. It's still nice out. It's kind of gusty. We do have, the wind has shifted 90 degrees and it's 20 knots, gusting 24, so it's a little gusty. Both Cleveland and Akron are reporting some mild wind shear at 2,000. That's about just below our pattern altitude. It's only a 30-degree wind shift, so I think we should be all right with that. I'm going to go up, just do alternator tests, and then I'd like to climb up to cruising altitude and just do a cruise speed test where I pull the engine back to where I normally would have it for cruise and see how it performs. And that's the plan for the test card today. Let's get the pre-flight done.
I had to take my sweater off. Yesterday it was 42 degrees, today it's 62. And inside the cockpit it's a little warm. I noticed the Comanche is gone. It's always sitting right here, and today it's gone. Wow, what is the wind doing? It is all over the place. But primarily from the south. So we're going to take off on 19. If you look at the birds, you can see they're all sitting there facing south as they're soaring. There's our run up. The 1800 on the ignition, electronic ignition, we have 10 RPM drop. On the mag, we have 70. No, 60. That's acceptable. Medina traffic, Cozy 797 Delta Lima departing 19. Light, trim set. $21.90, there we go. Wind is straight down the runway. Airspeed's alive, there's 40. And there's 50. We want to see that by the intersection, which you do. There's 60. And 70 and rotate. Everything looks good. Everything's still in the green. And gear up. And we'll pitch for VX. VY. It's breezy and gusty up here today. This is going to be fun landing. Alright, even with the warmer temperatures outside, the CHTs at full power climb, my hottest cylinder, number 1, is 387. That's well within acceptable limits. I suspect, as always, in the hot summer days, if it's 90 degrees out, I'm going to be bumping up against 400 on that cylinder. We're definitely not climbing as fast as we were in that colder weather as we were yesterday. We're doing about 750 feet per minute, 115 knots. Okay, so now I'm going to turn on the auxiliary alternator, and I should see nothing. It doesn't light up, and I'm going to turn off the main alternator, and I want to see this light up and turn on. And there it is. It lit up. And it turned on. So as you can see, the auxiliary alternator is now powering the airplane. It's putting about 22 amps, and it's lit up there. So that is working perfectly. It's smoothed out here now at 5,000 feet, so it's only gusty down low, which makes sense, which is why we were seeing alerts of wind shear down low. Okay, so holding it at 600 feet per minute at 6,000 feet at 100 knots. Backup alternator is still running just fine, producing 20 amps. Voltages look perfect. I'm just reducing my climb down to 500 feet per minute. I just want to increase airspeed a little bit because as the air is getting thinner and it's not capable of carrying away heat as well, it's not cooling the cylinders as well as it was, so my cylinder temperatures are creeping up. So now that I've jumped to 200 feet per minute in my climb, my number one CHT, which was at 397, is now down to 394. So let me bump it up to 700 feet per minute. And that was just a difference of 5 knots, and that made the difference in cooling. Coming up on almost 8,000 feet. And there's 9,500. Autopilot is pitching over. And we'll start to accelerate. Alright, so 167 knots true at 9,500 feet. Alright, and that's with full ridge. So now I'm going to lean it back to where I would normally have it. There's 7.1 gallons per hour. And we are still truing 160 knots. 160 knots at 7.1 gallons per hour. I'm very happy with that. Alright, next I'm going to take it down to 6,500, and then we're going to do the same thing again. So straight and level at 6,500, full power. I'm at 75% power. We're at 2590 RPM, 76% power, 168 knots. Now I'm going to lean back. Alright, there's our lean a peak there. 7.9 gallons. And truing at 162. That's pretty good for 7.9 at 6,500. Now I'm just going to mess around and go flying and stay up here where it's smooth and just look around and have some fun. Looking at a stadium with football players on it, Wadsworth High School. There's Wadsworth Airport right there. So looks like it's the home of the Wadsworth Grizzlies. See another airplane down there, right next to the stadium. About 4,000 feet below us, 3,700 feet below us. Looks like he's in the pattern for Wadsworth Airport. Is right over there. Alright, so I'm going to turn off the backup alternator. It has served its purpose, it's definitely working great. And then turn on the main alternator again. Medina traffic, Cozy 797 Delta Lima is 5 to the south. Command landing 19 Medina. There's no way I'm gonna make that. I gotta do a 360. Still way too high. Medina traffic, Cozy 797 Delta Lima joining the left downwind straight in for 19 Medina. This is the most challenging runway to land on at this airport because there's a displaced threshold, so it's short for me, and also there's trees and wires right across the road, which is the reason for the displaced threshold. So gotta pay attention here. Really watch my speeds. It is gusty. Gears down. Gas and switches. Gear boost pump. Medina traffic, Cozy 797 Delta Lima, left base 19, full stop, Medina. Landing breakdown. Medina traffic, Cozy 797 Delta Lima, final 19, full stop, Medina.
$500.
Speed's about right. Not a little fast. Power out. There we go. Right on glide path. Right on speed. Runway made, power out. Definitely gusty. Oh, a bounce. Little fast and bounced it there as a result. So now time to go pay the piper. Got to go fuel up, but I am very happy with finally got the auxiliary backup alternator working, and it is working exactly how I'd hoped. I can use it as a primary alternator. If my main alternator were to fail, I would be happy taking off and flying using just that alternator, just the backup alternator. It more than can run the airplane. It's got enough capacity to run the airplane with quite a bit of reserve left over. It did not overtemp. It had no problems whatsoever. In fact, it was just rock solid. So that's a thumbs up to Monkworkz. I'm very impressed with their both the quality of the alternator itself, the generator, and as well as the controller. The controller is just so well designed, really, really well designed. If you need a backup alternator for your airplane, your experimental airplane, definitely look at Monkworkz. Okay, well that's it for this video. If you have any questions or comments, please leave them in the comments section below. And if you like this video, click like and subscribe to the channel. Only about 20-25% of the people that actually watch my videos are subscribed to my channel, and I'd really like to get that up. And the more subscribers I have to the channel, the more people on YouTube it shows my videos to, so I'd really like to get that up. If you aren't subscribed, just go on down there and click subscribe today. And that's it, the end of my epic winter maintenance. This is the last maintenance video. From here on out, it's all flying. Thanks for watching.